Section 4.2 will start Unit 5, our last unit for the term. We will be working towards proving that triangles are congruent, which combines a lot of our topics that we've discussed this term. To do that, we need to first talk about Section 4.2, how to use congruent figures. Congruent triangles. Two triangles are congruent if their corresponding sides are congruent and their corresponding angles are congruent. And we've talked about corresponding parts in class. As we've sat in groups, we've talked about who's sitting in the same corresponding seat. When we talked about corresponding angles with parallel lines, those are the angles in the same position in their group. So these are corresponding sides in the same position are congruent, they're the same length, and the corresponding angles, the angles in the same position, have the same measure. Congruent triangles are the exact same shape and the exact same size. Here's an example of two congruent triangles. Down at the bottom, this is called a congruent statement. We have that triangle ABC is congruent to triangle DEF. This congruent statement not only tells me that the triangles are congruent, but it also shows me the corresponding parts. For example, since A is the first letter, angle A would be the same as the first letter in the second part, angle D. So those two angles are congruent. I could take the middle letter, angle B, I'm going to put 2 marks there, and it's the same as the middle letter in the second triangle, angle E. Then we have the third angles theorem, which states that if these two triangles or these two angles are congruent, then this third angle also has to be congruent. This is the third letter, C, is the same as F. The sides work the same way. If you take the first two letters, segment AB would be the same as the first two letters in the second part, segment DE. So not only does the congruent statement tell you that the triangles are congruent, but the letters in the same position show you the corresponding parts. So it's really important that we can read these congruent statements and that we're able to write the congruent statements in the correct order. This example says name the corresponding parts. So I'm going to look at the marks that are drawn on the diagram, and we're going to name all of the corresponding parts. So we'll start with the angles. This angle A has a single arc, so angle A corresponds with and is congruent to angle D. Angle B corresponds with and is congruent to angle E. Angle C corresponds with and is congruent to angle F. Then we can also name our sides. Remember, the sides of your triangle are segments. So we have the single slash on segment AB. That's corresponding to and is congruent to the other single slash, and we're going to go in the same order. If we go from A to B, see how that's the single arc up to the double arc? We want to keep this other side in the same order, from this single arc up to the double arc, so DE. It's very important these are in the correct order. If I do BC in my first triangle, BC, the letter B has 2 marks and C has 3 at the angle. I want to do the corresponding side in the same order. E has the 2 marks, F has the 3, so segment EF. Remember, these are points, so they're capital printed letters. If I do the bottom of the triangle as CA, C has the 3 arcs on the angle, A is a single. Then we're going to do FD, the 3 marks, and then the single. It's very important to keep these in the correct order. So those are our corresponding parts. We'll have 3 pairs of angles and 3 pairs of sides. Now we're going to practice writing some congruent statements. You need to be careful when you write the congruent statements that you don't stick with just alphabetical order, and that you really pay attention to your pictures, because what happens is we have this first triangle, and then the first triangle may have been turned or flipped or reflected so it's not sitting in the same position as the second triangle. So if I look at the first triangle, this says triangle ACB. So A, single arc, across the triple marks to C, 3 arcs up the double marks on the side to B, and then close the triangle. I want to keep my other triangle in the same order. So I'm going to start, since A had a single arc, I'm going to start at Z. It also has a single arc. Then we went from A to C. We went across the triple slash to the triple arcs. So I'm going to go across the triple slash to the triple arcs to Y. In the first triangle after C, we went to B, which is going across these double slashes to the double arcs. Same thing in the second triangle. Go across the double slashes to the double arcs to X and close up your triangle. So if you write a congruence statement, if I had ACB, I have to write ZYX. If you pick any two letters, for example, I'm going to look at B, the last letter, and X, the last letter, those should be congruent parts. Those are the ones that are both marked with 2 arcs on the angle to show that those angles are congruent. If I pick 2 letters, such as in the first one, I'm going to use AC, the first 2, from A to C, has the 3 marks on the side, then ZY should be the same. ZY does have the 3 marks. So your congruent statements, I should be able to look at and find corresponding and congruent parts. Let's try another one. This one says triangle BCA. So stop and look at BCA. B has 2 arcs across the double slash to C, which has 3 arcs, across the triple slash to A, which has 1 arc, and then we'll close the triangle. So we're going double, triple, single, arcs on the angles. So if you look at the angles, double, triple, single. I'm going to go to the other triangle, and I'm going to go in the same order. Double, triple, single. So B, the first letter, is the same as X, so that's our first letter. C, the second letter with the 3 arcs, is the same as Y, so that's our second letter. And A with the single arc would be the same as Z. So triangle BCA is congruent to triangle XYZ. Be careful not just to stick with alphabetical order, because these will be turned. Also, don't just look at it and say, okay, well, BC was the side on the right, because the side on the right here in this picture does not match up. On the right of the first triangle are the 2 slashes. On the right of the second triangle are 3. This triangle has been turned or reflected or flipped. It's been moved around so they're not sitting in the same position. Let's do one more. Try to name the matching triangle. We have triangle XZY. Pause the video, see if you can name the matching triangle. XZY goes from the double arc to the single arc to the triple. I'm going to do this in the same order. Double arc to the single arc to the triple. So I'm going to do BCA. And just to double check, I know Y and A should be the same. Y has 3. Oh, A doesn't have 3. I must have a mistake. So I'm going to go back and look at it again. We're going X, Z, Y. So X has 2 arcs, Z has 1 arc, Y has 3. So 2 arcs, B, A, C. Okay, let's check. Y is the last letter. Y has 3 arcs on the angle. C is the last letter. C has 3 arcs. The first 2 letters XZ, XZ has a single slash. The first 2 letters BA, BA has a single slash. So check for those corresponding parts. Make sure you have the correct congruence statement. We can also name corresponding parts without pictures then, based on how the congruence statement is written. So we should have 3 pairs of angles and 3 pairs of sides. So I'm going to start with the first letter. Angle M corresponds with the other first letter, angle E. The second letter, angle N, corresponds, so I'm just going to put and, corresponds with angle F, angle O, and angle G, because those are both last letters. Make sure that you get the angles. We also have corresponding sides, and these are segments. So I'm going to have segment MN. I'm going to use the first and second letter. And if I go first and second, I'm going to do first and second. So EF corresponds to that. Second and third is segment NO, corresponds to second and third, segment FG. And then I'm going to go segment OM, third, then first. So over here I would have to go GE. If you did MO, first and third, you'd have to do EG. You want to keep these in the same order as you write them down. So these are my 6 pairs of corresponding parts. Angle M and angle E are corresponding. Angle N and angle F, O and G. Segment MN, that side, and segment EF. Segment NO and segment FG. Segment OM and segment GE. We're going to do some examples with some figures, and you will have mostly triangles as we start to talk about these, but there are some other figures worked in. So we're going to start with a quadrilateral. Quadrilateral has 4 sides. This quadrilateral happens to be a trapezoid. And so we're going to use our congruence statement. We're going to look at our corresponding parts, and we're going to solve for the variable. So we have 2 variables in these pictures. We have an x and a y, and we'd like to solve for each. So we're going to start by finding x. So to find x, I know this 4x minus 3 is this side hj. So I could take my 4x minus 3, and I know since these 2 figures, these quadrilaterals, are congruent, that hj should be the same as whoever corresponds to that. But my figures have been flipped and turned, and I'm not really sure who goes with hj. So I'm going to go back up to my congruence statement at the top. hj, h is the second letter, h is the third letter, j is the second. So that corresponds with cb. cb is 9. So the 4x minus 3 must be the same as 9 because these are congruent figures. Then we're going to solve for x. So I'm going to add 3. 4x equals 12, and divide by 4, and x is 3. I wasn't asked to plug back in for any measures, so I'm done when I find x. Next, we're going to find y. So I'm going to look at my diagram and find the y. We have 5y minus 12 is this corner angle at h. H is the third letter, so that angle H would be the same as the corresponding letter. H is the third letter, C is the third letter, so it's the same as angle C. Angle C in my other figure is 113, so the 5y minus 12 is the same as 113. If we add 12, we get that 5y is 125. Dividing by 5, we get that y is 25. So we've solved for x and we've solved for y. You need to find those in your figure. Use your congruence statement to find the corresponding part. Set those equal because we know they'll be the same. The figures are congruent. Let's do an example with a triangle. We still have all of the information that you previously know about triangles. We know the interior angles add up to 180. We know an exterior and adjacent interior, those two right next to each other, add up to 180. And we have that special rule about remote interior angles and the exterior angles. All of those things are still true as we're looking at figures. The congruence statement for number 2 says that triangle ABC is congruent to triangle DEF. Okay, ABC, we have some information. We know that angle A is 22, angle B is 83. I don't know angle C. For triangle DEF, I know that F is 4x plus 15. So somehow I need to find x. So let's check and see who 4x plus 15 is the same as. F is my third letter. C is my third letter, but I don't know what C is. However, I do know that C is the same as this 4x plus 15. So I'm going to copy that over. When we fill that in, now we have all 3 angles of this triangle. And we know those 3 angles add up to 180. So I'm going to add my 83 plus 22 plus 4x plus 15 and use the fact that those interior angles add up to 180 to find x. Let's start with like terms. 83 plus 22 is 105 plus 15 is 120. So 120 plus 4x equals 180. To get all of our numbers to the right, we're going to subtract the 120. So 4x equals 60. 4 and x are right up against each other. They're multiplied, so we'll divide by 4. And x is 15. I found x, so I'm done with the problem. I wasn't asked to plug back in. Example 3, we have triangle ABC is congruent to triangle DEF. Triangle ABC is the one on the left. And again, you can visually see that this has been reflected. It's been flipped over. Angle A is 100 degrees. Angle B is 45 degrees. Angle C is missing. I have marks on D and E, but I know that F is 4x minus 9. So if I look at angle F is the third letter. That's the same as angle C. So again, I'm going to copy my 4x minus 9 over to angle C. Now I have all three angles in the triangle. Those should sum to 180 because the interior angles of a triangle always add up to 180. So I'm going to take the 100 plus 45 plus 4x minus 9 and set it equal to 180. Like terms, 100 plus 45 is 145. Minus 9 gives me 136 plus 4x equals 180. Again, getting x by itself, we're going to subtract the 136. So we have that 4x equals 44. To get x by itself, we're going to divide by 4, and we get that x is 11. When you come into class, we'll be working after a short review on page 205 to 209. We're going to do problem numbers 4 through 14, 24 to 29, and 41 to 57.